Okay, folks, good morning. We're going to get started. Thank you for sticking around, day 3. Welcome to MED402, building a scalable video digital asset management platform in the cloud, or DAM. I'm going to say DAM a lot today. DAM. Anyone ever see Joe Dirt? Yep. DAM. Okay, so with me today, by the way, I'm Mike Limcaco. I'm a solutions architect with Amazon Web Services. And with me today is Jonathan Rivers from PBS, Director of Technical Operations. And together we'll describe some general best practices for building a scalable DAM in the cloud. We have a lot of material to cover. And in fact, because this is a 400-level session, our goal was to dive deep into some bits of code. We will still do aspects of that, but in the interest of time, we may be jumping ahead. Now, we will try our very best, just to give you a heads up, to open source and or publish the bits of code that we'll be talking about today. So the agenda before you is pretty straightforward. We're going to provide you with a general overview of the big picture. What's the context for DAM in the cloud? What are some conceptual, logical, and physical architecture approaches to realize that picture or that vision? And then we'll go ahead and open up the kimono and actually build out aspects of a DAM platform in the cloud. Now, by the way, absolutely recognize that there are existing DAM solutions out there today. There are DAM platforms, there are marketplace offerings, there are standard shrink-wrap products. Absolutely recognize and appreciate that. The goal of today's discussion is to dig a little deeper if for whatever reason you need to engineer your own equivalent solution or build or extend an existing capability that you have today using the concepts that we'll present. We will also show a representative client experience and how that might lay on top of the cloud services that we're talking about. And then, of course, we'll shift over to Jonathan and team and talk about how PBS continues to successfully deploy these types of concepts in their operations today. And then finally, we'll wrap it up and hopefully we'll leave some room for Q&A. So again, just to level set everyone, the focus of this particular session is comprehensive enough to cover the general pattern of media ingest, storage, and discovery across the board. However, we do want to pay special attention to the pro-media side of the house because we tend to give a lot of love, rightfully so, to the user-generated type of content, consumer-generated content, and their specific workflows. For the next 50 minutes or so, we'd like to spend a little bit of that time in addressing the pro-media side of the house. If you're a broadcast or an organization that's responsible for producing feature film content, original content, mashed up content, you're very familiar with the idea that you have to take in large amounts of source material from various sources, not always digital, at least not originally, staging that into a number of storage architecture options and progressing that through a workflow such as transcode, transmux, conversion, downsampling, and such, and then pushing that further down the chain up to the point of presence where creative actors or creative workers, consumers, editors, assistants, everyone who's a part of this organization can find that content and make use of it. So that said, media asset management is a big space. We're going to focus this discussion even further on the actual storage, metadata management, and discovery aspect of this entire workflow. Conceptually, where does that fit in the big picture? It's the items you see highlighted. All of these parts, of course, extremely important, but discovery, delivery, and how you access that content, obviously very critical to your user experience. So what are some key business or functional requirements that are a part of a typical DAM initiative? We can see here that across the board, there's a number of key features that any comprehensive DAM solution should deliver, from ingest to metadata extraction, pulling out the technical bits of information and user-generated annotations, pulling that out, saving that off to a database or making that discoverable, creating renditions, and renditions have different, there's a different context for renditions depending on where you're coming from. This could be a low-res proxy, that could be mezzanine files to help enable the actual post-production process, or it could be browsable adaptive bitrate web data sets that I could look at on my iPhone. So creating renditions from original source material, that's obviously an important part of the DAM solution. Building the catalog, being able to discover the various data sets according to different dimensions, that's obviously critical. Enabling rich search against those data elements. And finally, as a complementary set of features, managing the overall storage lifecycle and providing efficient delivery of those media assets, whether we're caching that content or providing a streaming experience to the end consumer, trying to make sure that that discovery process is closed in an effective way. And of course, we want to do this at scale. It's so important to realize that with the increasing amount of content, variety, velocity, and veracity, content is just growing, different formats, different standards, different consumers. We have to address the idea that this platform needs to scale. Many of us in this industry can appreciate the fact that with increasing resolution, for example, 2K, 4K, and beyond, we're just looking at massive amounts of content. Professional organizations creating feature film content are easily hitting multi-petabyte range for finished content. It's mind-boggling to think about how much content's being captured by raw camera sources on set. If we could just pick up that raw material and make it available for the larger consumer base, there's just great potential for that. But we're talking about massive amounts of content, petabytes easily. And of course, between the different formats, standards, codecs, resolutions, end device types, it's becoming an increasingly challenging problem. Cloud, as a business enabler, allows us to start thinking about opportunities in terms of how to take advantage of cloud services like near infinite storage to be able to enable the capture and the persistence and the discovery of some of that traditionally unused content that is left on the cutting room floor, for example. What if we could actually persist that, store it efficiently at a cost-effective rate? There's a potential new business model for that. Search specifically is an interesting challenge because we have to deal with the wide variety of structured, semi-structured elements that are a part of the technical header of any container. The challenge here, of course, is that there are so many ways to call an entity a specific term. The concept of codec, for example. The term codec might appear in container X as a certain string, and yet in another container it might be described as a numeric. This is standard, typical data modeling challenge, a standard, typical data modeling challenge that we can address using some of the concepts that we'll talk about today. All right, so why don't we go ahead and dive deep? Let's go ahead and look and lift the covers a little bit and start building out aspects of this solution. So I'm going to switch gears here and show you an example of of course, it's my EC2 instance. I'll just bring that up again in a bit. But let's take a step back. Here's the use case. I'm a media organization. I'm doing collaborative work. We're creating some original and maybe not so original new content, mashup from original material that might be available to us. We're going to create some new interesting web features that incorporate content from other digital providers or digital sources. CodeRush 2010 is over 100 tapes now digitized of content from a movie that was produced in late '99, I believe. It was on PBS at one point, and it describes the trials and tribulations of the Netscape and Mozilla project team in the late '90s. It's actually kind of a cool project. You should watch it one day. But the idea here is that we have a collaborative work group. They need to find content that's a part of this. They need to scrub it. They need to annotate it. They need to identify interesting snippets, push that up to a common, persistent, collaborative location, and make it available for other users in the team. So I could, for example, be a user who has access to a logging tool like Prelude. I could have the digital media available to me, and I could be scrubbing through the various assets, looking for interesting areas to pull out for our feature film. And we may identify a section where throughout the clip in one of the Scrum meetings at Netscape, we see a gentleman, an engineer, using some interesting ancient device, and we find that kind of cute. So we decide to go ahead and mark that as an interesting clip for further use. And again, just recognizing that there are standard tools and techniques for this. The user can go ahead and use the tools that they know and love, and at some point we need to bridge into the cloud, and that's what we're going to do. So a user would go ahead through this logging workflow, identify snippets that were of interest across the breadth of the raw content that they had collected. They could then go ahead and, using the tools that they're used to today, whether it's Prelude or Avid or Final Cut Pro, they can go ahead and save this to what they think is a NAS device or a local storage system, and behind the scenes, we've actually mounted that. Could be a variety of technologies. We've mounted this user experience so that when they save those files, it's actually getting uploaded to the cloud. You could be using, for example, Aspera or Signient or CloudOpt. I actually happen to be using BlackBerry Drive, Cloud Drive. Did I say BlackBerry? Sorry, guys. Cloudberry Drive, which allows me to basically take content from my file-based workflow, copy it over to a shared drive, and have multi-part upload kick in and thread up to the cloud. Behind the scenes, we'll pick it up in the cloud, ingest it, extract metadata, register it in the catalog, and make it searchable. Well, what does searchable mean from a user experience perspective? Let's go ahead and sign into our portal. This is a representative user interface. I actually have this built out, hosted on Beanstalk. A user may, for example, be presented with a home page that shows them the different bins, the different projects that they've been working on. Behind the scenes, we'd be storing these containers which represent what content they've collected and annotated. We'd be storing the metadata behind this in at least Dynamo, for example. If they wanted to upload through the browser interface, they could use the browser interface as well. Let's say some box art. They forgot to upload some box art. They want to go ahead and upload that. Throughout this entire process, they also should have visibility into the activities of the system. I should be able to, for example, understand where I am in the ingest pipeline. Where's my rendition workflow? What's happening with that? Well, ultimately, at the end of the day, what's important to them, what's important to us for this use case is search and discovery. And this part of the system is, in fact, hitting Dynamo and Cloud Search, and we'll talk about the details behind the scenes. But right now, we're going and hitting a fleet of Beanstalk managed servers, which are then propagating back to a number of search capabilities in the form of DynamoDB and Cloud Search. As you would expect, I'm able to preview web proxies. All of this, of course, would have been pre-processed ahead of time through the services that we have, such as Elastic Transcoding Service. We could also look at the technical metadata if it was important. We can go ahead and click that. and find all the technical metadata that was extracted as a part of the ingest activity. But going back to our story about the Mozilla Netflix use case, we're interested in finding clips from that original 1998 film. So I'm going to go ahead. I know our team in a remote location has scrubbed it, they've logged it, they've metadata tagged it, and they've ingested it into the cloud. At least they've told me that that's the case, so I can go ahead and start searching. So I can start searching by title. Maybe there's some aspect of the title. It's called Code Rush. I know that they told me that there was specific formats and codecs that they applied during the transform process. So I could go ahead and say, limit my search to AVC or H.264. And I do my search, and the system will go ahead and filter those clips as appropriate. Now, I know that the logger, as a part of that initial workflow, identified specific scenes and specific subclips within these larger clips. Wouldn't it be interesting if we could go ahead and introduce that concept of almost object recognition without actually throwing in computer vision technology? We're going to use the human, we're going to use the logger, the assistant editor at the beginning of this workflow who tagged the content at specific points of the clip to find these relevant pieces that we need to work on further. So I'm going to go ahead and type in, look for track marker comments where the word unique was used, or classic, or I like, I love this. Again, it's a little bit of an artificial example, but you get the idea that we can come up with a mechanism where loggers use specific tags, and we could search for those tags and not just do a dumb kind of search. This is very specific. It dives deep into the actual technical metadata to pull this out. And in fact, yes, we find that this is the clip that we wanted. There's a comments button that's activated, which will park me right into the section of the clip, pulling from S3 or from CloudFront back to S3, and then using the still emergent but very useful media fragment URI RFC from the W3 org to be able to peek right into that clip, to be able to specify from a URL perspective where I want that range request to park itself. So this is taking advantage of effective bandwidth. It's also parking me right in the section that I want to be in, and we're also painting back the clips that were tagged as a part of Prelude. All of this is available today with existing capabilities. There's no magic here. It's all about integration and laying it on top of Amazon Web Services. And finally, wish I had more time to actually build this out, but there's a button somewhere here that says, I like that clip. I now want to order it and use it as a part of my post-production workflow. I don't want to have to download the full gig, the full 20-minute clip. I really want just that 60 seconds of interesting content. Go pull that back from the system. Well, between S3 and CloudFront supporting range requests, and moreover, recently, very recently, last Friday, the ETS team announced clip generation. So with all the metadata that we're able to extract out of this that's available in our DynamoDB and Cloud Search content that's coming back, we could actually initiate an API call to ETS and specify the clip marks that I want, the start time and the duration. So very cool. At the very end of this job, once I submit this job, I can go ahead and submit this job and imagine if it was integrated into the GUI. Oh, well, of course, it wouldn't be a demo if I didn't have a red box. But like a good cooking show, I've got the turkey all finished, ready to go. So that actually came out of Elastic Transcoder Service using the new Clipmark feature. So now I have 60 seconds of content that I was able to discover from someone who had marked it previously as a part of their workflow, uploaded it to the cloud, found it, and pulled it out. And now I can continue with my post-production activity. So kind of cool. All right, so let's talk architecture. So how would we build something like this? How have we built it? What are some of the patterns we see in our customer spaces? Before we start talking about Amazon Web Service components and technologies, I think it's a good idea to talk about the conceptual building blocks from edge in green, from edge and customer-facing components to, I need my mouse here, edge, middleware, media verticals, and storage and discovery. The system would be wired using these concept building blocks. The flow is users would integrate with this cloud DAM platform using their file-based workflows. Remember, we want to be as non-invasive as possible. That content would be discovered by a number of middleware agents. They would basically be monitoring for ingest activity and then emitting events, notifying interested parties. Those interested parties would then pick up the remaining requests from a queuing construct, and in the first case, perform rendition, processing, creating thumbnails, low-res proxies, mezzanine files, and in the second case, running in parallel, extracting metadata. And possibly you could see yourself looking at this saying, you know, there's way more things that could be added to that entire workflow. Yes, we could start adding, in a very scalable way, we could start adding additional plugins down the pipe for things like computer vision, scene recognition, watermarking. There's other things we can continue to add to this pipeline. At the end of the day, the bits, the pixels, the video content gets stored in a back-end store, and it gets cataloged and synchronized to a front-end catalog or database. And from a user perspective, they interact with this back-end persistence layer through a user interface, through an API. They discover content. They request that content be delivered, and it has the potential to be streamed out through a delivery cache. The tools that are available to us to build out this vision are listed here. I think it's all pretty obvious to us in this room. You're at an AWS conference. We might expect to see a couple of our services in the third column. That's not to say that any objective solution needs to be limited to those, but for today's discussion, we're going to focus on these. Ingest, S3, great, obviously great candidate for near infinite amount of storage. For metadata processing, we're going to have to introduce some media vertical components that ride on top of EC2. I find it even easier if we outsource some of the building blocks that are required to make that scalable in the form of auto-scaling groups and load balancers and monitoring and logging by putting all of that in Beanstalk so you can put your API servers behind Beanstalk. Creating renditions. Again, Elastic Transcoder is a great option here. Of course, we also have partner solutions out there that can hit the breadth of raw media types. And catalog processing itself, I'm going to hit this in more detail in just a minute, so let me come back to that. Storage and delivery, of course, we have Amazon S3 and integrated potentially with Glacier, where you can set up lifecycle policies to age some of the content out to a lower cost tier of storage. That's the S3 to Glacier lifecycle integration. And then, of course, CloudFront for integrated streaming, progressive and download streaming from your source database. Okay, as far as the actual core of this discussion, the DAM catalog, I'm recommending, at least for this discussion, that we talk about a uniform search interface that's actually enabled by two parts. Dynamo would, in my mind, provide the aspects of administrative entities, or it would support administrative entities persisting information about users, groups, projects, the mapping between projects and content, administrative entities. I think this is a good candidate for Dynamo. DynamoDB, of course, has all the great capabilities of a managed NoSQL service offering. It's multi-AZ in nature. You don't have to worry about it. You provision the IOPS. But from a data modeling perspective, as far as the core content itself, I talked about administrative entities. What about the core catalog data itself? DynamoDB makes a great candidate for storing the breadth of your catalog metadata because it does make allowances for a varying set of data models and metadata elements. If your container A, container B, and container C all have different definitions and different layouts, whether it's XMP-based or Dublin Core or FCXML, you're going to be able to utilize DynamoDB's very flexible, no model, no schema mechanism to kind of mash those up together to normalize that into a flat data space. And because we're not doing heavy transactional work against this catalog, it's really queries. It's not as critical necessarily to run this in a relational construct, although you can. And then the other aspect is actually searching against that entity, that catalog, that integrated catalog entity. Cloud Search, of course, is our managed search service. It allows you to go ahead and define indexes or indices, which will allow us to search against these various metadata elements. And there's strong support for features such as case folding, stemming, stop word removal, setting up synonyms. How many times have you seen H.264 spelled out H.264 or AVC or advanced video coding? What if I could just aggregate all those so that when I search against one term, I get hits against all the relevant companion data sets? Cloud Search will allow us to do this. Finally, some other goodies that might be possible in a DAM solution, at least in the one that I presented. They include broad use of the AWS CLI, the command line interface. It's such a great tool set. It's been incredibly enhanced in the last couple months. In fact, the demonstration I showed you and all the backend infrastructure that we hope to open source is less than 400 lines of script code built on top of the CLI. Fantastic stuff. Some open source decode utilities to include the use of media info and Exif Tool. These are great for extracting and peeking at the technical metadata behind these media assets. There's others, of course. There's Apache Tika. There's FFmpeg even. But these tools I have found to be very good at picking up some of the more subtle data elements in these metadata fields. We're using Talend for some of the complex ETL pipeline work to be able to transform some of the metadata models between the different container types. That's just a representative solution. And then finally, from a front-end perspective, we're using Node.js, the AWS Node SDK, and for those of you who care, AngularJS. Finally, let's go ahead and build this out from a technical perspective. This is the architecture enablers all wired together. You can see the different piece parts. As you might expect, S3 providing that storage backing. We have a singleton, in this case, a singleton EC2 node, auto-scaling group 1, max 1, min 1, which is basically monitoring the state of ingest activity on S3 buckets that have been designated by the organization. It then goes ahead, it finds new content being ingested into the system and sends a tickler through the middleware stream through SNS. SNS has two SQS queues which are wired up to the SNS inbound topic. Every time there's a new event, the rendition jobs get kicked off and the metadata processing jobs get kicked off. And then, of course, we have some EC2 instances with the appropriate bit of software that we talked about, such as media info, Exif tools, and the AWS CLI, which enable the rest of our architecture. The key piece being extracting that metadata, normalizing it, and then persisting a copy to DynamoDB, and then using some of the new CLI features, synchronizing the record between Dynamo and Cloud Search, providing a unified API for users, portal experiences, so that when they do hit this box, they really don't care if they're hitting Dynamo or Cloud Search. They know that they're getting fast, multi-dimensional queries answered very quickly. There are parts of this architecture that I'd like to show you, and I do apologize, we are running a little behind, so I will speed things up here so that we can get to Jonathan's section. But I'm going to go ahead and log into EC2. Okay. Maybe not. Let me check my security groups. I apologize, folks. We're just going to check our security group settings here real quick. .32. And if we don't get this in 1 second here, I'm just going to go ahead and punt it. Of course, our address got switched. Brain surgery on the fly. All right, apply it. All right, let's try that one more time. Okay, well, let's go ahead. Let's just move forward. Do apologize for that. What we can do is we can show you at the end of the metadata extraction process. Here's the quick walkthrough. We basically set up the buckets. We make sure that we have a staging area for receiving content from edge locations. We wire up, we define an SNS object and wire it up to 2 SQS queues. We create a DynamoDB and Cloud Search index. We create a DynamoDB table using a defined skeleton of a schema as a starting point. You know, we are talking about a no schema solution or a NoSQL solution, but we do have to start with something. And in this regard, I recommend using a combination of XMP and Dublin Core as our starting point skeleton. Once those are all set up and wired together, as we step through the workflow, the system will monitor the ingest of new files getting copied up to the cloud. We have an EC2 Worker, which is running in an auto-scaling group, multi-AZ. It scans S3 for the staging content, and then it moves the content to another bucket and informs the rendition threads to start their job. The workers for processing the metadata receive event notification through SNS and SQS. They're just constantly polling the SQS queue looking for new work. In that queue message is a tickler along with a pointer to the actual content, an S3 URI. That worker picks up that new content and broadcasts a new event so that the metadata extractors that are running downrange can pick up that work and run Exif Tool and media info to process the header data and store that in DynamoDB and Cloud Search. One part that's pretty challenging is normalizing the content that's coming from these open source utilities. As they extract all the technical metadata from these various container types, we need to normalize that and make it palatable for DynamoDB to be able to ingest. And this is where we utilize a tool like Talend or any other comparable tool set to help us do some of the complex joining and transformation of the model mediation process. Yeah, it's a lot to say. What we're really saying is, given various container types, given different tools that extract that content and the layout they put these data fields in, we need to be able to mash them up together, normalize it into a manner that's friendly to our data model. So we're running media info, we're running Exif Tool, we're running the AWS CLI, and we're running Talend on EC2. Once that data has been injected into Dynamo, it's really just a matter of hitting an extra CLI call to synchronize Dynamo with Cloud Search, and then making that search available through an HTTP call. And my last little bit here before I hand it over to Jonathan is to show you what that final result looks like. That final record that gets stored in Cloud Search is available through an HTTP URL. It's a simple GET experience. And if I go to, just a sec here, I actually use a RESTful test client. You could use curl, but I already have the actual query that we generate that's part of the protocol that Cloud Search expects already filled in. I click Submit, and basically what comes back are a number of JSON elements, 28 records, and each record has a number of core elements, and that's what gets processed and presented in the user experience. So with that, I'm going to go ahead and turn it over to Jonathan for a discussion on some real-world examples of how they've applied the use of Cloud Search and other enablers in making this solution successful.
Awesome, thanks. So I'm Jonathan Rivers. I'm the Director of Technical Operations at PBS. I want to talk to you about our CMS and DAM system. We call it Merlin. Merlin is our primary authoritative metadata repository. So it is both the back-end system as well as the front-end system that our folks get their media into the system with. So it's structured metadata. We bring in about 200 web objects daily. We've got about 30,000 web objects in the system. They ingest about 150 video objects daily. We have 91,000 videos in the system now. We generate around 200 hours of video every week going into the system. We have users from over 150 of our member stations and 30 national producers. So what does it do? It's a large multi-tenant system. It has about 1,200 registered users. This is the system that gets all of the video into our video portal, to our over-the-top applications, to our mobile clients, everything. It does about 250 million streams per month. We service about 20 million unique viewers, and we deliver about 8 petabytes of video monthly. So how do we get the data in? We're moving increasingly towards automation. So for a lot of the web content, the URLs, instead of crawling them, we use RSS feeds that are programmatically ingested and set up by the content editors. We have a batch video ingest API, so instead of a user having to go in manually, set up all of their metadata, say I want this image, this video, they can just go ahead and post that to an API and let the system go ahead and do it, so that way they can have programmatic workflows to get the stuff in a little bit faster. Or finally, they can go ahead and do manually entered videos in the system. This is a quick overview of how Merlin works at a very sort of high level. On the left, you have all of the inputs, so the user input, the ingest API, and the RSS, and that's coming into Merlin. Merlin is all run in EC2 in auto-scaling arrays. It is backed by an RDS utilizing their read-only slaves. So when content comes in, it's handed over to the workflow service, which has image transformation, video transformation, transcoding. It's storing all of the files in S3 and fronted by a CDN. It then registers with our content APIs. There are actually 3 different APIs that power Merlin, and we'll talk about that in a little bit. And then finally, there's a search utility service that goes and pulls all of those APIs, gets the information about the content, and throws it into Cloud Search. So talking about the basic workflow for a minute, the object is registered with Merlin. A user goes in, they create a video, they use an API. So there are three basic things that are required for any piece of video content in PBS. It is a mezzanine video, a closed captioning file, and a mezzanine image. So the videos are registered with our video transformation service. That sends a job to Zencoder for transcoding. We're currently cutting about 11 different copies of every video that are going into the system. And then those are stored in S3 and fronted by CloudFront or another CDN. And then once all of that image transcoding and video transcoding has been done, it then registers with the three different APIs and makes the objects sort of discoverable. So making it discoverable to all of the clients that consume it, when I talk about the Cloud Search clients, we're talking about our video portal, our over-the-top applications like Xbox, our mobile applications, rather than actually the digital asset management system itself. That's handled by simple Django search. Everybody knows what they're looking for. They know what they created, so there's not really a search problem there. The search utility service runs every hour, and when it runs, it actually pulls about 3 hours of data. Our APIs are all pretty heavily cached, so it's possible when it runs, it might not have the last set of updates. So we always want to make sure that we're going back, looking at the modified times, and getting any records that we don't have. So it hits those APIs, uses the modified time, and then updates our Amazon Cloud Search index. We're running 2 indexes primarily, one for all of the Merlin content, all of the video content, and then the second one for our shop objects that are actually populated by ingesting a spreadsheet. So a couple of things for PBS when we're talking about this, the Cloud Search implementation and making the content discoverable. We needed hidden objects, so we had to have the ability to have objects in the system but not have them in the search results. This is sometimes done for embargoed videos, some things for our press tour, or maybe just even internal content, right? Some of our internal training videos, things like that, are in the system and can be consumed by some clients, but we don't want them showing up in search. A second is rights management. Some videos are only available in certain places, so they might be available US only, they might be restricted just to the UK due to a licensing arrangement, or in some cases available only in a single state. So we needed ability to tailor these results so that users are only getting content that they can see. And that's sort of dovetailing into the partition search. We run video portals for all of our stations, and what we want is when a user comes in and does a search on the video portal that they're going to get results that are local to them. So they want to see the shows that are on their member station and maybe not another member station, right? So if somebody's from Minnesota, they might not be interested in the content on Idaho or Virginia's sites. So the other big thing that it allowed us to do, which is really the big deal, is it allowed us to flatten our data model. So we have 3 different APIs that are being pulled for small pieces of the data, and by flattening it in Cloud Search, it allows us to build one record that has all of the information that we need, so that way any client that's consuming it then doesn't actually have to go make 3 separate calls. They can just call Cloud Search, get one fully formed record, and not have to deal with the overhead of doing that on themselves. So from there, the other big search consideration was we found that when our viewers are coming to the site, they're looking for specific programs, and that made our life really easy. It made it really suitable for structured data. They're just looking for a program title, and then that's generally what we're giving them back. So challenges of implementing Cloud Search for us, they weren't particularly legion or difficult. There's no native time field, so we needed to convert all of the dates to integers and use epoch time, and then the versioning of the documents was a little rough for us as well, and again, we use epoch time for that. And then we needed to go ahead and basically have two versions of most fields, one that was just text searchable and another's faceted for ease of search implementations. So I want to talk a moment for the actual search consumers themselves. So on pbs.org, when somebody is performing a search, they might search for Masterpiece or Downton Abbey, for example. And what we want to do is pull all of those results that came in from those web feeds, right? So all of their site updates that are handled in RSS and imported into the system, we're going to get them the results in the center section. And on the right-hand side, we're actually making a separate cloud search call to that second index, our shop index, and returning objects like DVDs, books, things that are in the PBS shop so that they can go ahead and purchase those if they want. The second big consumer is our video portal, and the search here is handled in two main ways. The video search itself, so they're looking for Downton Abbey or Masterpiece, and it's returning that program. The second place is really sort of a neat thing for us. We use it to generate our program's A to Z list. So we've got a lot of different programs, and we've had a lot of different programs over the years. And what this allowed us to do, instead of having to manually curate a list of our programs, so anytime the content team dreams up a new program or a station has a new program, we don't actually have to go into a list and somebody put it in and what the URL is. We're using Cloud Search to go ahead and generate that list so that it's always up to date and somebody's not in there tinkering with it all the time. And finally, we're using it for our Xbox and our OTT applications. These are fairly straightforward program searches that are returning results. It's not super complex. So that's a pretty good overview of how we have all of that. Still got a couple of minutes left, like 13 or so.
Okay. Yep, so we'll just wrap it up real quick, and then we have room for a couple questions if anyone has questions. So again, hopefully with today's session, you've seen that a DAM scalable cloud solution is not only possible, it's enabled through our services and implemented very successfully in the context of large operations like PBS. There's many services to choose from. We offer one example of a reference architecture that can be built out with a number of managed services to enable it, such as S3, DynamoDB, Cloud Search. And finally, we also talked about the importance of recognizing that there are other components that sit outside the cloud ecosystem that complement any objective solution, and we should always consider that. And finally, everything that we've talked about today is highly scalable, always wonderful to talk about the capabilities from an enterprise perspective, and with Jonathan's discussion at PBS, hopefully you can see how that's all real. So thank you very much. We're happy to take questions at this point if you have any questions.